Swayam Prabha. Digital India. Educated India.
Okay, so previous lecture was mostly a motivation and overview of where stochasticity and these stochastic networks, how can you make it reliable to the extent that you want. And the motivation was only to motivate you that there are very interesting practical problems that you see in the world whose solution actually comes from mathematics. But unfortunately, the mathematics is little advanced, so I cannot talk about the details of it. But hope we motivated you to do mathematics, especially probability, and calculus will be very useful. And physics, lot of physics. There is chemistry also underlying, because when you make those circuits, there is lot of chemistry goes on, but unfortunately I am like not at all knowledgeable about it, so I won't speak about it at all. So the next part is, we'll play a simple problem, we'll take a simple problem of this information networks, social networks, which is a stochastic and information networks, and we'll try to solve a particular problem at our level, at +2 level. Okay. So the problem is the following. Let's see how an opinion is formed in a social network. Okay. How do you form opinions? For example, Tamil Nadu, yeah, we had an election recently, right? So think of, you are not eligible to vote, so yeah, unfortunately. Many of my first year's advisees, they voted for the first time, so some of them are quite excited. So maybe next 2029 you will be able to vote, all of you. Good. So suppose there is a binary choice. So I won't go to Indian elections, I'll just stick to US elections to avoid controversies. Okay. Just so that I don't take any false steps. Okay. So there are two parties. One is R and one is D. You know what it means if you follow US politics. And suppose R stands for 1 or 0 and D stands for 1, whatever. And suppose there is a friends. Some friends are there who talk to each other over Instagram or Facebook or Twitter, whatever. What they do, 3-4 months before the election, they start discussing whom to vote for. Okay. And how the discussions flow, everybody has their own belief or opinion based on the information they have and their personal preferences. So everybody has a hidden belief. So everybody has a hidden belief. Right? Now, if you are friends with somebody, you will express the belief to that, because you can trust that person won't rat you out. Okay. So you can express the belief, and the person may also say, maybe no, I believe it differently. Okay. Now, suppose you are meeting for coffee or tea, like few friends, they'll discuss with each other. And based on the discussion, my belief will change. Maybe they'll shade some more information or more light on something, my belief will change. Either it may get stronger about what I had. Suppose I had a belief that I want to support D. Then maybe it will get stronger or maybe it will get weaker. So what will happen? Over time, will evolve. Okay. Over time, it will evolve and it will convert somewhere. Just before the election day, there will be some numbers. Okay. So that's how opinions generally evolve. Now let's look at the caricature model. A simple model. The model is the following. That I have a belief, suppose this guy, my belief is some number which is XA. I am A, my number is XA. What is capture? This is a number between 0 and 1. Just a number between 0 and 1. Now what is it trying to capture? Anybody, what? Exactly. So 0, 1, a number between 0 and 1. Where have you seen that? Like a number which always lies between 0 and 1. Probability. So this is capturing probability of choosing D is XA. So I have a belief that D is better for my country, or D is better for me, that is XA. Okay. Now what I'll do, when I talk to my friends, this XA will be a number. Suppose if I'm very strongly believing in this, it will be more than 0.9 or something. So what I'll do, I'll express some opinion to my friends. How would I express? It's like when I'm expressing my opinion, the way to express is with probability XA, I'll say something very strong about D, very positive. So with probability XA, say positive about D, right? Now I have friends. Who are friends? Whoever has connection to me. If I have connection, they are my friends. If I don't have connection to this is not my friend, because I don't know how to reach it. This is my friend's friend, not my friend. So I express something. My friends also do the same thing. They also have XB. This friend has XC. Right? So at a particular day, on a particular day, so what I do, A does, so on a day they meet. What A does, A expresses opinion. And how does it express? With probability XA, it says something positive about D. How do you model it? How do you mathematically model it? The model is, have a coin with bias in this case, probability of head XA. What does it mean? Everybody knows about coin toss, right? So if you toss, probability of getting a head is 0.5, half. So what you know, so this part is something which is maybe I'm not. So generally fair coin, what we call fair coin, probability of head is half, equal to probability of tail. But I could have a biased coin. Yeah. No, I did not follow. No, the X is the probability of choosing D. So, for example, if I am completely unbiased, X will be half. So, suppose in this case, so XA half is means unbiased, or what you call in political term undecided voter, who have not decided anything whom he wants to vote for, like it's totally on the fence. I have no idea whom I want to vote for. Okay. So this is called unbiased or fair. A biased coin is when you toss with a probability which is not equal to half, you will see a head or a tail. Now why is it that is called unbiased? So biased case is, so biased probability of head is not equal to probability of tail. That's the biased coin. Now how would you figure out something is biased or unbiased? Huh? Very good. Very good. So what I do? I take the coin, flip it for 500 times, 100 times. See how many times I get head. Okay. So how to get pH? pH, you get toss 100 or 1000 times, count number of heads divided by total flips. Okay. So what does that mean? That also means for a biased coin, if I toss many times, I'll get more of heads or more of tail. If it's unbiased, I toss many times, most likely I'll get equal. Okay. So now you see why we are trying to model the bias using XA. What will happen to the guy who has a probability of head, or in this case we'll call it D, is XA. That means if my XA is close to say 0.9, take an example, XA is 0.9. So that means if I toss 100 times, most likely 90 times I'll get head, or which is our D. That means if you ask that guy to say something about, yeah.
So there is no way to quantitatively get a bias value.
XA is the bias value.
So how do you get that value?
You are saying like, how do I know what's your bias? Yeah. That's the same way. I ask you the question, if I am allowed to ask, whom would you vote for? Okay, and there are many people who do survey. And suppose out of 100 times you said 90 times I'll vote for D, then your XA is 0.9. But that is not allowed generally, because that's in democracy is not allowed. So we'll see that without knowing your bias, can I figure out something? But if I am allowed to do that, then I can get your XA. So that's why this XA, I use the term hidden, because it's generally your personal thing. You don't share. You're not supposed to share. Unless you are a vocal proponent of a particular political party, you should not talk about it. Okay. Fine? So now, I know few things. What? Suppose this guy has a bias XA with 90% chance or 0.9 probability, you will say D. Same with this guy XB, same with this guy XC. Okay, everybody is on par page with this. Now, let's look at the following. The next step is interesting. From where we'll build. Suppose on the meeting, A expressed an opinion which is a coin flip with XA, B same thing with XB, and C same thing with XC. Yeah.
So if we are having a fair coin flip, in that case, the probability of heads is always 1/2, right?
Yes.
But if you have a biased coin, let us say that we do a survey of 500 tosses, and in that 500 tosses, we get 490 heads.
Okay.
So the probability of heads is 490 by 500, right?
Yes.
So then if we subtract, if we do 49 minus 50 minus 1/2, won't we get the bias value for that survey?
Oh, you want to get how far it is from half. That's what you are calling the bias. Okay. Deviation part. Okay. See, generally what happens in this biased coin toss, people call the probability of head itself is bias. When it's equal to half, we call it unbiased. Otherwise, we just call it a general biased coin toss. A technical term for this, which is not part of your +2 syllabus, I am not sure. The term is, it's a Bernoulli coin toss. Heard Bernoulli? Okay. This is called Bernoulli P. So term for this is Bernoulli XA. And people generally don't try to understand XA minus half. If you just get XA, that's good enough. Because after that you can always do XA minus half. If you get XA, XA minus half is nothing to be done there, right? Good, very good. So now let's come to this. Now they meet for some time over coffee. A says something about I want to vote for D or R depending on this coin toss, right? So most likely if it does a coin toss, it would be either D or R. Each of the result will be D or R. Each of the result will be D or R. Now if his XA is 0.99, with very high chance that this will be D. Suppose this guy is 0.05, not just 0.5, 0.05, very small. It would be mostly R. Okay, so something like that we will see. Some opinions being spread. Just imagine in your head that you belong to a particular political party and your friend belongs to a totally opposite. You meet, you express opposite opinions.
So I have a doubt here. So for XA is 0.9 meters. Like if A is a supporter of R, then why would he ever vote for D?
No, the thing is this. Nobody is a fully ardent supporter. Only unless you work for a political party or you're like member of a political party or something, you'll be a supporter. Most of the common people you're still thinking. Means if you ask your parents who are not part of politics, they're still thinking right before entering, pressing the button. So their minds are still improving, and when they're changing, on that particular day, the EVM button, before that actually their mind, what they did, they flip a coin inside their mind with that probability. Maybe that's the right decision, and they put the coin. Okay. So there is this theory called in mind what goes on in something called, heard of Roger Penrose, everyone? Roger Penrose, he's a Nobel laureate, 2022 physics Nobel laureate. So he worked on black hole and all, and is a theory of brain, where he says the brain is actually some kind of a quantum is going on in the brain, and right before you make a decision, there is something called a state space collapse, which is like a similar to this. You are having this belief going on, and right before you make the decision, somebody is flipping a coin inside your head. I mean, you can think of God is flipping a coin inside your head, and you are getting that decision. People who are completely committed, they are like XA is 1. So every time you toss, you will get the same thing. Okay. Fine? Okay. Now, if suppose I take a scenario where this guy got D, this guy got D, and this guy got R. Suppose this is called a particular realization of the coin toss. This is called a particular realization. Like suppose I make 3 coin tosses, I'll get a particular realization, head, tail, head. Okay. Next time I toss, I'll maybe getting tail, tail, head. Yeah.
So, in this case, when you're talking about people meeting,
Uh-huh.
should we also count the bias that the other people can influence a particular person's opinion?
Exactly. Very good. Very good. Very good. That's the next step we are going. Okay. So what we are saying is, these people, how do I get other person's bias? I can't read inside their head what is their XA or XB. I can only get when they say something. My friend said something, they expressed an opinion. Based on that, I can see, okay, maybe they are saying we should go for D. So what will happen in this case? Most likely, a thing is, suppose they are very good friends, like they just trust each other completely. A will look at what are my other friends are saying. What do they feel versus what I feel. This guy sees, in this case, that I believe in D because that's my XA, and the other my friends, one says D, one says R, right? So it's like equal. They're like undecided. Like, so if both of my friends, very close friends whom I trust, one says this and other says totally opposite, what do I do? Most cases, I just ignore both because they are like conflicting. I can't accept one versus other. I stick to what I was doing. So what will happen after this? So they will kind of update their belief based on interaction. This guy will mostly stay same as XA because there is nothing to be done, right? Because my two friends are on two different extreme, I can't go with either, and so most likely I'll stay in the middle what I was doing. What will this guy do? Look from this guy's point of view, it's again the same. This guy also two friends extreme. So he'll stay the same. What happens to this guy?
Both are the same, so the influence to change is
Exactly. Very good. So now what will happen? For this guy, the XC was some value of getting D. That will increase now. Because both of my friends are saying D. So maybe I better adjust myself. Maybe I am wrong. So what will they do? They'll add some delta to it. Some value. Okay? Yeah.
But this might also increase the probabilities of the previous two people, right? If the third person changes, then they may feel more confident and their probabilities would have increased.
Exactly. So that's the next step. Next step is, so this meeting they made for some time. This is the opinion exchange, it happened. Now this thing is done for the day. Maybe tomorrow they meet again, or maybe next weekend they meet again. So next time what happens, they express their opinion with these coin tosses now. So XA again does the same coin toss, which is Bernoulli XA. It does the same guy, Bernoulli XB, and this now has a change XC, which is XC plus delta XC. Now they toss the coin, maybe this time it gets R, maybe this time it gets D again, maybe this time it gets R. Yeah.
In the third case, the XC was initially 0.05, a very small value. So that means he or she was totally favored towards R.
Huh.
So there can also be a possibility that whatever their friends say, they can still remain with R.
It can.
So in that case, delta XC will be.
Delta X will be very small. So what he said is true. How much do I change? That depends on how much I trust my friends versus my opinion. Suppose I am a very headstrong person. Yeah, I'm a very headstrong person. I don't believe in anybody. I just feel whatever I think is the most correct thing. I won't change at all. My delta XC will be 0. But if I'm a guy who is willing to trust others, my friends, then my delta XC will be different. So what happens is a very important thing in network, depending on the person's trait or personality trait, the value of delta XC will be different. Maybe for some it will be exactly 0 because they'll never change. They believe in that, they'll stay there. Delta XC in this case, particular case, we are treating it positive because this 2 is del D. So it's trying to move towards D by influenced by friends. But what you said, it can be negative in the following way. Suppose it turns out that I have friends, but I feel these two friends of mine is totally ignorant about politics, so whatever they do, I should do the opposite. Yeah.
Sir, I got a logic for like if A and B alone means it. Let us assume like A likes Democratic Party for like 90%, B likes it like 40%.
Okay.
So if they are neutral, it will be like 50%. So
Uh-huh.
so A is plus 0.4B.
A is?
Plus 0.4. 40%.
Okay, okay.
And B is minus 0.20.
B is minus 0.1?
40%, 50, he likes it like 40%, right?
Uh-huh.
So 50 minus 40 is minus 2.
Oh, okay, okay. Uh-huh. Okay. So you're just talking about the bias. Okay.
Yeah,
The
then
difference.
finding like average of it,
Okay.
then it is like 0.15.
Yeah, so you're just doing the average. So the average is an interesting idea. So there are certain models for this evolution where they just take the average of XA, XB and update. But what happens there is in reality, I can never know what's your belief. You actually also do not know exactly what's your belief. Nobody knows. Only thing I can know what you say, what you express. So generally a more practical model is I have a update my internal belief based on what you say, because I do not know exactly what's inside your head. I can only know what you wrote on Twitter or what you told me in person. You had a question, someone? Ah, yeah.
So this will work only if both of them impact each other equally, right?
There are different models. You can model it as equal influence depending on, suppose you are very good friends and none of you are headstrong. You just trust each other, then it will be equal influence. But sometimes it could be unequal. For example, suppose you kind of look up to a friend, then that person will have more influence on me than you will having the influence on this. For example, a simple thing, suppose I follow Virat Kohli on Twitter. So officially on Twitter basis I am friends. But definitely what I say has no impact on Virat Kohli. But what Virat Kohli may say may have impact on me.
But if it's equal impact, what he said will work.
Exactly, that will happen. But that's see, this what he is saying, that's a model. That's also people think of equal influence networks, like where networks of peers. Like for example, teachers, they're all equal, they're all friends. That's a equal influence networks. Or my colleagues, like me, Keshav and Rupsa and all, equal influence. But similarly, suppose in that same thing, there is, my director is there. That's not equal influence. It means director's influence on me is much more than my influence on the director. Similarly on that, now you are the education minister. It becomes even more unequal. So it depends. Very good questions. Yeah, go ahead. Huh? Very good. So there are scenarios where you can show that we'll never converge to one answer. And that never happens in a democracy. We never converge that everybody, have you ever seen in US that 99% people voted for democratic? It's always 51 versus 49. So that's why it often can happen, you'll never converge to one thing. And that's the beauty. That's the beauty. What you want to understand is it may not converge, but what would be the percentage so that we can predict who is going to win. Okay. For whom it's important. For suppose tomorrow US goes for election and India wants to hedge its bets on certain geopolitical strategy or certain business strategy. So we want to understand who will become the next president. Suppose if Donald Trump, then maybe war in Iran will continue, will suffer with our Hormuz and everything. So India has to plan differently versus somebody else. So that's why that prediction is very important. It may not be 100%, but I want to accurately predict what percent, and so that I know who will win. Okay. But here the problem is different. Here we actually want to understand, I'll come to that. Here, so this is evolving like this. So on day 1, so this is my opinion on, this is the expressed things on day 1. This is expressed on day 2. So similarly, we'll have day 3, day 4 and so on. Okay. No, in this case, because what happened for XA, it says I am XA, I would change if my friends ask me to change, like based on my friend's opinion it changes. Here I see both of my friends are on 2 different extremes. So they kind of cancel each other out. So nobody pushes me. But for this guy, I'll come. This guy, he says I am on R, but both of my friends on D. So they're kind of pushing him towards D. But for this guy, there is no push. Both are equally cancelling. It's like 2 vectors in opposite direction, they cancel. Okay? Yeah, I had a question. No, this is just a coin toss. So these are all independent coin tosses. So on this day, I suppose XA was 0.9. On this day I tossed, I got democratic, D. Next day I toss, even if it's 0.9, there is a 0.1 chance I'll get R. It's a different, these are called different realization. This is called a particular realization, this is a particular realization, and they are independent. So it's like, suppose you have a coin which is most likely to fall head all the time, 90% chance. But if you keep tossing, sometimes you'll get head, sometimes you'll still get tails. So exactly that is happening. Until and unless XA is 1 or 0, there is always a chance of getting the other thing. No. The values have changed from XA to delta XC, but here now I am tossing the coin again, independent of the previous toss. So now this is a new toss. So independent means you can think of it's like a new toss. Because now my new opinion, I sit together, now in my head, somebody asks whom are you voting for? Somebody flips a coin inside my head, and this time I say this. Okay. This is a caricature model, things are little more complicated than this, not this simplistic, but we'll stick to the simple model. Yes.
Then how would the model proceed if it reaches like a state of equilibrium where one person's opinion is negated by another person's influence?
That's something called, but that will never happen permanently. For example, just look at this guy. Why that this guy did not change? Because they were negating and I did not change. But suppose I don't update, but I next day, suppose my XA, XB, XC are remain same, but I meet again. I may not get the same pattern. Maybe this time he will also become D. In that case, I'll change. So it's almost impossible to stay in one place. You'll always keep moving. So there is no what you call a physical equilibrium, like there is no potential well where it will always drop and stay. What it will reach to, just to give a very brief overview so that you get interested in future, something called a stochastic process equilibrium, which is a stochastic equilibrium, which is not a potential deterministic point like a ball rolling through a potential well. It's an equilibrium where statistically I remain the same, but not deterministically. So that's something which I cannot get into the details, which is a very interesting idea. And by the way, in all of you know thermodynamics, right? So the thermodynamics is the macro scale phenomena. Like there is a micro scale explanation of what you are seeing. Okay. So to understand that, there is something called statistical mechanics, which goes to understand it. So when you see a system is in equilibrium of temperature, like say two copper blocks heated at two different temperature, I put them together. After some time, they will reach the same temperature and we will think it's in equilibrium. That's what 10 standard plus 2 standard physics tells us. But if you go deeper inside what's happening, they are not in equilibrium. Heat is still flowing between them at a micro scale, which is at an atom scale. At an atom scale, heat is still flowing. But at a statistical scale, they are in equilibrium. That's why when you measure, you see the temperature is same. Because you cannot measure one particle, what's happening to them. You can only measure the effect of all the particles together. Something very similar happens in these networks. You don't reach to a particular point that A always becomes D or R. They keep fluctuating. A, B, C, D are individual particles of the system. But as a system whole, they reach a statistical equilibrium, which is a very interesting thing. And it's a fascinating thing in the sense that's exactly what happens in nature. You rarely reach a perfect deterministic physical equilibrium in most systems. But that's for your, when you go to college, we'll discuss this. That's little bit more probability. Okay, that gets into, that's a one of the fascinating use of probability in. Okay, now let's come back to what we are planning to do. So these things are happening. Okay. Now suppose I am the outsider, I am not the friend. And suppose they're meeting not in a cafe but on Twitter, and they are saying tweeting something. So first time the A tweeted about D. We should vote for D. This guy said we should vote for D, and C said we should vote for R. Next day they tweeted something else. I only see that, nothing else. By looking at that, can I figure out if A, B, C are friends or not friends? So suppose, so let me write the concrete problem. Suppose we only see the opinions on different days. The question is, can we decide whether A, B and C are friends or not? So that's the question. They are friends. If they are friends, they'll evolve like this. If they are not friends, how will they evolve? They'll just go on doing the same thing, XA, XA, XA every time, XB, 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 coin toss. I have been given day 1 DDR, day 2 DRD, day 3 DRR, something like this. I just get to see this. From that, can I figure out if they are friends talking to each other or they're just doing it independent of each other, like not even talking to each other at all? Huh? Good.
All of them are hard-headed friends, then even though they're friends, they're probably
Exactly.
So in that case, how would you prevent?
Exactly. So if they are kind of headstrong friends who don't talk to each other, we'll consider them as not friends. Like, it's like, what kind of friends you are if you don't exchange ideas? In this context, they'll be not friends. We'll treat them as not friends. If they are not at all listening to each other, we'll call them not friends. Okay. Now this problem may seem little unethical to you. Unethical in the sense somebody is trying to snoop whether somebody is friends or not. Okay. Now let me give a different twist to the problem so that you see that. So I work on this problem. Okay. By the way, my PhD student and I have been working on this. And this gets into very serious math which we cannot get into. If you want to know the math behind it, I'll just write the name so that in future you know what to look for. It's a very fascinating area of probability and mathematics. It's called learning. Everybody has heard of AI, right? Everybody has heard of AI? Has anybody heard the term machine learning? Yes. So this is machine learning. This is called graph learning. Okay. It's a area of machine learning called graph learning. And unfortunately, your ChatGPT or other things cannot do this. You can't throw even a neural network at it. It's a harder problem. You have to do it very mathematically. So when things get harder, the only option is mathematics. Okay. So that's where you survive. Learning causal graph. Causal graph. Not visible, right? Okay. So I think the red color itself is very faint. Let me take a different color, blue. So let me say it. It's called learning the causal graph of a, you can write it, learning the causal graph of a high dimensional Markov process. That's the technical term. And I'm sure you have not heard of any of those terms, but those are very fascinating areas in learning the causal graph of a Markov process. So that's a technical term, but we won't do that. We won't do that at all. What we'll do a simple game which is very easy to play and a caricature version of the game. So what I need is each row form a team, okay? In each row do I have, so sir and madam, can they use smartphone as allowed? Okay, okay. Just open Google, okay? And just say flip a coin. Just go to Google, say flip a coin. Google search, everybody knows how to do Google search, right? Just, yeah, and mine means it's not, I did not know. I did not know how to open a computer when I was my +2. We did not have computers, so flip a coin. So that's what all we need. So what we'll do is the following. We'll play, each row has at least 3 people, so that's fine. So let's play the following game. Very So with this Google coin flip, this is like a proper coin flip. If you say flip, it will flip a coin and get head with probability half and tail with probability half. Now suppose I ask you the following. Give me a biased coin flip using this. You won't have anything else. Which flips a coin with probability 1/4 head. Can you create that using this? So I have one coin which is fair. So if I toss it, I'll get with probability half head, probability half tail. I have only given you that as a resource. Now ask you to generate a biased coin toss whose probability of head is 1/4 and probability of tail is 3/4. Very good. So what we have to do is just toss it twice. And if both are head, then only I'll declare it head. That will give me, so let me write it. What happens? I have head and tail, both are half. If I 2 tosses, I have head, tail, head, tail. What is the probability of this? Half into half, 1/4. And each of them is 1/4. Now if I say I'll toss it twice, after that I'll declare it head only if both times I got head. Right? So that's one way of creating a biased coin toss. Now let's play this following game with this idea in mind. Suppose my network is the following. The influence is directional. Like think of, they are like big guys influencing a small guy. It's like think of this is Virat Kohli and this is Rohit Sharma. And this is me or this is you. I have no influence on Virat Kohli and Rohit Sharma. The influence is the other way. Okay. So what will happen now is they will say something, democratic or republic. And that will influence me and I'll change in the next step. Okay. Now, here the way we'll model it using your game is Virat Kohli and Rohit Sharma, they are standing on the fence. They are undecided. So they are both bias half. Okay. Fine. Now, if both of them said D, say both D, then what we do, you or me, we say D with probability 3/4. Like 75% chance I will be what both Virat and Rohit is saying. Okay. Fine. Now, if one or none says D, in that case, I will be also undecided and I will say with probability half, I am D. So that means if both of them are unison, they are saying something. Yeah. Yeah, you can model it like that also, but I am just keeping it simple. That's a good point. So you can have 3 layers. For example, one says D, I am this, and none. In that case, maybe I can be Bernoulli 1/4. That's the most practical thing, but I just did not want to complicate the game, so I am just making it simple. So it's like one or none, and let's, okay, just so that the game remains simple. Now this is what will happen. Now what I want is, in every row, one is Virat, one is Rohit, and another is normal human being like you and me. Let's play this game. Okay. What do you have to do is only keep one note. Okay. Head, tail, head. Okay. Head, tail, head, head, tail, head, head, tail, head. Just the way you document is, you just write in the first term what happens, or let's call it D, like D is head for us and T is R. Let's just document that, what you got. Okay. From that, the game will be the following. You keep a note of, in your head, that what is the first row. First row is Virat, sorry, first column is Virat, second column is Rohit, and third column is something else. Or whichever way you want to order. The idea will be, after you note it down, you pass it, swap it with your next row. Just by looking that head, tail, D, D, R order, the other guy has to figure out who is Virat, who is Rohit. More importantly, not Virat, Rohit, who is a normal person. Okay. Huh? So, in each row, one of you, be like Rohit or Virat, like toss a coin half-half. And the third person behaves like the normal person, you, me. So, Virat, Rohit will have this flip coin toss on your Google, half-half. And the third person, depending on what Virat and Rohit did, will toss the coin with probability half or toss the coin with probability 3/4. How to toss the coin with probability half? Just button. How to do this? Right? If this is 1/4, if you don't get it, that's 3/4. Right? So do that and then record head, tail, head, head, tail, head, head, tail, head at different trials. After you record it, don't mention this head to Virat or this head to Rohit or this head to a normal person. Don't mention it. You order it any way you want, but keep a note of it separately, secretly hidden, and switch with your next row. Then that row will also do the same thing, and the goal is, can you figure out, just by looking at it, who is Virat, who is Rohit, who is the normal guy. Just do it for 10 or 15. Less than that, you may not see anything useful. Or shall we ask you to play, because we don't have much time, right? 5 minutes. I don't think we have time to play 10. So I'll say try it among your friends. Everybody got the game clearly? Okay. Everything is clear? So try to play this and let me know what goes on. Okay. If you don't get the solution, I'll talk to, where is Grakesh? Yeah, Grakesh, Harini and Ria. So I'll share with them how to solve it. Okay. That's part of their intern project. Okay. It's a very simple way. I have given you purposely the simplest version of the game. They will be solving a little bit more complicated version. So think about it. How can you solve it? It's like it won't come to your whatever JE test or anything. This is hard enough for JE, but you can think about it. It's a fun problem, but you can solve it based on the knowledge you already have. You don't need to know anything. Whatever you've done probability, right, already, so you'll be able to solve it. All of you said in unison, do you understand that probability of head half is, if you toss 100 times, most likely 50 times I'll get head, 50 times. Try to use that intuition and it will work out. Try to use that intuition. Think about it, okay? Play the game. It's a fun game. You can, after you have mastered the game, go back and play with your friends in the school. Okay. Fine? Okay, so we'll end it here. We have 5 more minutes. If you have any questions, you can ask. We don't have time to play the game, but maybe it's played best in leisure time. But as I said, try to use the fact that if you toss a coin with bias X, suppose the probability of head is X. If you toss it 100 times, how many heads you will get? 100 times X. Say X is 0.9, it will be 90. Try to use that intuition and see where you can use. Okay. You will be able to solve the problem. Think about it. But this is the simplest version of this problem. This is not the most practical version. As already he mentioned, I just ignored this case, just to make it simple. You can add it, things can get even more complicated. So how do you solve it? That gets a little tricky. That's the most general problem. But this is the version that you can solve just based on your +2 knowledge. Nothing else is needed. Nothing else is needed. Don't worry. Whatever is done, you know it can solve it. It's a puzzle. Okay? Any questions so far? We had a lot of things discussed. First part was fully motivation. Second part was I was trying to show you some approach so this part what I have been doing here, this is a very important thing in engineering called modeling. It's not the fashion modeling, it's called mathematical modeling. What it means, take a real problem in life. It may be how to send data, or it may be to understand how voting ideas are evolving. All those things. And how to mathematize it. Mathematize is a very important aspect of engineering. See, all of engineering is essentially science and math. Physics, chemistry, math. Or if it's bioengineering, then a lot of bio is also there. So science plus math is engineering. The question is, how do I see an engineering problem, use my scientific understanding of it to transform into a math problem? That's all is engineering. Actually, that's all of you do. If you go to physics class, you play with the pulley problems. What are you doing? Essentially looking at it, transforming into bunch of equations. So you are looking at the physical system, writing the math. Because math is the only thing that you can solve. So it's always looking at the physical world, transferring into math. In physics, in +2 physics courses, we do it so intuitively that we don't see the difference. But as you grow into higher and higher physics and math, that becomes more and more challenging. How do you mathematize it so that it captures the essence of the real world, at the same time you can solve it? So it's always a trade-off. All your physics plus 2 problem, you can always exactly mathematize it and exactly solve it. That's great. But as you go more and more complex physical and engineering systems, you cannot exactly mathematize it because that becomes too complex. So you have to capture the essence of it and mathematize it and then solve it. So how do you do that? That's a major part of engineering. Okay, that's a major part of engineering. So I just was trying to show you that. And this is a caricature version of the mathematized problem that is right there. I caricatured it and I'm just asking you, try to solve it. You can solve with your plus 2 knowledge. And there will be more complicated version. Hopefully Harini, Grakesh and Riya will solve a little more complicated version. If you want to learn from them, you can learn from them later. Okay. Okay? Any questions so far?
All three players are influencing each other. Won't there be a continuous change in opinion?
Very good. So what is asking, if all three players are influencing each other, when things will flow in a continuous way, and can I then distinguish if I influenced you or you influenced me, because it's kind of circling back? Yes, that's a very interesting question. You can do that. There is something called cutting in time. So at one time the influence flows is this direction, you can focus on that and see what's happening. You can solve it, you can do that, that's possible, but that's not possible with plus 2, so I won't talk about it. It's possible, it's very good question. It's possible. It's called circular influencing, or what you call, yeah, let's not get there. Okay. But it's possible to solve. Okay. Very good. If I have any question, keep asking. Something will be solvable with plus 2, most things won't be. I'll point you to what to read. But in future, if you get interested to know who is influencing whom and all, that's a technical term. You can't read the papers on this topic now. You can ask ChatGPT to summarize something in plain English. They'll tell you something. Most likely they'll do a good job because there are enough papers in it. So most likely they'll do a good job, but I'm not fully sure. One thing only I will end it, the power of mathematics. Okay. I'm sorry, madam. Sorry. Okay. 2 minutes. I'll only show this problem with social networks. Okay. The same mathematics, exactly the same mathematics, is very useful in understanding the following. So, as you know that we understand very little of human brain. How human brain works is still a big part of it is mystery. Suppose I just go to board and write 4 plus 8 equal to 12. So people try this in labs, ask somebody to write and see which parts of the brain is coordinating when I solve 4 plus 8 equal to 12. Which part of the brain is coordinating when I solve the equations at 3x plus 4 equal to 10. It's more likely higher and higher part of the brain will be activated when you solve harder problems. Versus, I just have red and blue and I ask somebody to point red versus point blue. Which part of the brain is activated? There will be different parts. Now, how do you figure out which parts of the brain are working so that I can figure out a color versus I can do the math? The only way, they take lot of experiments. Like I also been part of these experiments in my PhD. When my lab mates will do, they'll put EEGs in your brain. Like you have seen EEGs, they'll put it on your head, a cap, and they'll ask do this, and they'll record your EEG signal, and they'll ask you multiple times, 4 plus 8, one problem, maybe another is 3 plus 7, they will ask you, and they'll record the data. And based on, and they'll not just for me, for many people. Based on the data, they'll try to figure out which part of the brain is actually influencing another part of the brain for solving the problem. So what happens, not one part does it. One part fires something called neuron signals, that triggers another part, that triggers another part, then that may fire back and trigger me again back. All those things happen. That's almost like the social networks. Like I express my opinion, that influence somebody, that may come back and influence me. So the same mathematical formulation that is useful to solve this is useful to understand what is happening in brain. The same mathematical problem is again useful in understanding which company's stock influences which other companies. And that's a crazy thing in IITs is many of your seniors, they just want to go to finance companies. So their goal is to understand that, which stock influences which company. Same math, exactly the same area. So that's the power of math. It abstracts out. It does not worry about what is the real problem there. The mathematization is the part which takes you from reality to math. So you can call math lives in a different world, but it is always in this world also. So it lives in a different world, but is also inside the world. It's kind of out of the world, but through the world. It's a very interesting idea. The only parallel I know of is in Indian philosophy. You guys are not supposed to know it. There is a concept called Brahman and Atman. If you see Bhagavad Gita, which says, who is through the world, but again not in the world. So math is also like that. Math is in the world, but again can be out of the world. It can be in the world in such a way that the same math is useful in 10 different things, but still it's abstract, it's just numbers. Where is numbers? Numbers is in your head, but numbers are real also. Temperature is a number, it's real, but again number is an abstract thing. 35 degrees Celsius and 35 is different. So it's a very interesting thing. Math lives 1 foot in the world, 1 foot out of the world. It's like the Trivikrama Murti. 1 foot is the world, 1 foot is out of the world. It's a very interesting thing. So I just want to get you motivated by that. And also explore simple harmonic motion. Everybody studied? LC circuits? Not yet. LC circuits? Capacitors, you know. Inductors, you know. You can put R and C, capacitor and resistor in a circuit. You can put inductor and capacitor in a circuit. Okay, maybe you'll say it's 11th standard, right? So 12th you'll learn. That's in 12th. Simple harmonic motion and electrical circuit are very different. There is no connection almost physically. But when you go and solve the math, you'll see LC circuit and the simple harmonic motion is the same mathematics. So that's the first exposure to abstraction of mathematics in +2. And as you go more and more, you will see that more and more. Simple harmonic motion, and one is a mechanical thing, another is an electrical thing. They are exactly the same math. Okay, thanks, and again welcome to IITs, and thank you, madam.
We sincerely thank you, Dr. Avhishek Chatterjee, for your insightful and engaging session. Your introduction to networks, stochastic concepts, reliability, and quantum circuits gave us a new perspective on complex systems. The way you explained the caricature model, along with the probability-based problem and the interactive coin toss game, made the session both engaging and intellectually stimulating. Thank you, and we are truly grateful for your time and inspiration.